Practical Tasks. Bur 2. C Programming with Nucleo 411. Introduction. The lab experiment focuses on programming the Nucleo FR4 objectives. Implement threads, mutex, priority scheduling, and The result for Task 2A is observable on the breadboard through the selective illumination of the output LEDs. The successful illumination demonstrated the ability of the Nucleo 411 board to activate and deactivate output components on an external breadboard. The result of this task was visible on the breadboard. When the input signal of the switch SW1 is received by the Nucleo 411RE, only the yellow LED, LED2, is illuminated, and when the switch is released, the result of Task 2C was observable on the breadboard through the timely activation and deactivation of the output LEDs.
Going to task 2D, we need to run multiple threads with round-robin scheduling. Notice that all the threads spawn at the same time despite sleep are called in all of the threads. This is because the function of multi-threading is to run the program concurrently, and the OS will automatically ignore the sleep. Notice also, the order of the threads are not guaranteed in round-robin scheduling. This is because all the threads have the same priority, and the order of the thread spawn depends more on random factors such as where does it store in the memory, which the user has no control on. Notice if I restart again the program, thread will still spawn randomly. Yeah, always 132, it depends on the seed of the generator.
Moving on to question 2e, the task requires us to run multiple threads with specific priority. The question requires us to run 5 threads with different mathematical equations in specific order. This was done through the set priority methods that you can find on the worker threads. Notice when I press the button, all the threads spawn in this specific sequence. Let's watch it again. And there you have it. They always start with C, D, E, B, and lastly A. All of the calculation of the threads was verified against the theoretical result, and we can see that it is verified. And thus, that's how you set the priority of all the threads in Mbed OS.
To demonstrate task 2F, I have pre-recorded the video on my cell phone, and now I will explain the operation. The last task simulates a digital parking system and utilizes all of the knowledge of threading that we have learned previously. There are 3 external buttons in total being used to control the system. The first button will activate all the threads inside the program and act as an on switch for the system, as if the system was being turned off during the night time. The second and the third button will increment and decrement the parking count accordingly. Let us now start playing the video and see the operation. We have here the parking is being closed during the night time, and when I press the button, the parking is being turned on. You can see the left button increments the parking count, and the right button decreases it. All of the incrementing and decrementing was kept track by the car park thread that also handles the reading of the buttons, while the display of the parking count was handled by the display trap that prints the output at a regular interval. That's all. Thank you.